Now let's start solving. This is going to be of course the solving video. Also I didn't disclose this in my first video, sadly, or like the explanation one. Everything here is of course my information. You should do your own studying. I sadly did do, I think, solve the first 5, but they could be done by calculator anyway, and I think I will show you how. You shouldn't worry too much about me scribbling on the paper, by the way. I tend to do that a lot. Now, the first thing that you do want to do, if your calculator does not have, or like it does have the complex, is that you want to go to mode, and then you want to press on complex. Now, how do you access the I, or like the thing? You press the ing or whatever it, I don't know if you can see that. Wait, oh, I just flipped it, sorry. It would have, it's already labeled, so I and then whatever power you do want. There are some specific calculators that can do this a lot better than others. This one can go up to, I'm pretty sure, power 4. Nope, not that either. Crazy. It can only go up to, I think, power 3 then, if so. Yeah, it can go up to power 3. Other than that, it will not go much higher, sadly. Yeah, there we go. Okay. Now, to get through this really quickly, you can just do all of them. I already have it solved out. These all are just basic calculator. And I do not know why this light keeps switching off. You wanna make sure you're using brackets and everything, and it would give you the answer, which is correct. Of course, you do this also here, here, and then same thing with the multiplication, I believe. Just to make sure, I'm just gonna do one of them. Plus 4i. That, what? Oh, is there supposed to, yeah, there isn't. Yeah, it is correct. What? I'm not looking at the right question. Let me just put check marks. I'm actually gonna lose track of the questions. Let's also try the power 2 one. Yep, it does them all, I believe. Even the fraction. Just in case. 3 plus 7i. And then you'd go down. 5 minus 3i. Yeah, it does them all. So we can just check those off. Now, you wanna... This is, I think, what the majority of the I is going to be about on our test. Now, simplify 925. Remember what I said? You divide 925 divided by 4, which would give us 31.25. And what did we say if it didn't give us a whole number? If it didn't give us a whole number, then it's just going to be I. Now, just to make sure, we could also just divide it by something. We can try dividing this until it gives us like a full number, which is 231, and then we'd count after it. Since we already divided it, it's going to be, if it's divided by that, then yeah, there's only one I left. Now, 460. Same thing, 460 divided by 4 is going to be a full number, so it's going to be 1. We can already check off this and that. Now, remember how we talked about how complex numbers are basically just 1i is equal to, let me just write that down, 1i is equal to root -1. Now, this is -16, so this is going to be 4i, since what's the root of just normal 16? I'm pretty sure you can also do this on the calculator. Yeah, -16, yeah, 4i. Now let's exclude the I for a second, or the negative. Root 16 is 4, since we already know that I is equal to -1, -1's root squared. So you just put I instead of that, since it already has a negative inside. And with this, you just use the calculator too. -8. -8 is going to get you this, which is correct, 2i. Now, what if you repeat 2 squares, right? 2 squares is basically to the power of 2. But just just in case. Yeah, it's basically to the second power, which would mean this is just -6, since you could just combine these and say it's -6 to the power of 2, which would eliminate the square root. Now what if it was like this? You have negative obviously inside of the square root, which would mean this is -5i, not -5, what? This would be 5i, and then you'd have +4, which is a real number. You cannot combine the real number with the complex number. Now, these are all done by calculator, I believe, but we can go through them really quickly, since I did promise to solve this whole sheet. 1 minus I. This would be this. Oh yeah, 28 minus 24. Yup, it's going to be A. Between brackets, 5 plus I. Bracket again, 7 minus 3I. It's going to be 38, -8I. And now we're back to simplifying large exponents. 101, let's divide 101 by 4. It would be 0.25, so this would mean this is just I. And to make sure, let me just look through it really quickly. Yeah, it's going to be I. So depending on what it gets divided by, so if it's any number, let me just put that, any number. So if it's 0.25, that is equal to I. If it's 0.50, it's equal to -1. If it's 0.75, it's -I. And if it's just a number, which is 0, I guess, it would be 1. You just want to keep that in mind. Now the whole idea is to not add them together. You cannot add different exponents at the same time. This would cause a problem, and I don't think this is worthy of using a calculator either. So we could just solve this by hand. Let's divide 11 divided by 4, which would be 0.75, which was -I. And to the 12th power, is going to be supposedly 3, which is a whole number. It would be 1. I believe that is, wait, is that 13 or 12? Anyway, we do not see the answer for -I, -I plus this, so we can cross out this being 12 anyway. Let's say it was 13 instead. If it was 13, it would be I, which would then result in 0, which is the correct answer. This is just bracket -3 -I, then 4 and -2I. In brackets, you want to make sure that all of your brackets, all of your signs are correct, or it would give you a completely different answer. This would be incorrect. Let's be okay. I bracket 7 -3I, which would be 3. Yeah, it would be D. Now, when you're dealing something like this, this is I power 2, so this could be instantly translated to -1. And -1 and -16 would be -17 over I plus 4. So you could just plug this into the calculator already. Don't forget your signs like I just did. -17 plus I Wait, no, it's negative 17 divided by I plus 4, which would look like negative 4 plus I. A. Okay, this is I power 2. I genuinely cannot read whatever these numbers are, but let's just say that this is I power 2, which would mean this is negative 1. So 2 over negative 1 is obviously negative 2. Then you have whatever this number is, which I cannot read again. But what type of print is this, dude? I think this is 3 over I. Let's try to see if it gives us any of the answers. 3 over I plus 2, or let's just for the sake of it put I power 2, which would give us D, which is actually the correct answer. So this is a 3 for everyone watching, I guess. Now this is I power 3 plus I power 2. I power 2 is already negative 1, and I power 3 is negative I, which would mean it is D. There we go. Now we're done with the easiest part, I believe. Yeah. Now I think we've all been informed that the teacher doesn't actually want us to factor this. They just want the two solutions, zeros, intercepts. So we can just cross out this and we just want solutions. There are two ways to solve this. There is either the factored form, which we already see over here. So this is, you're going to switch the signs of each. So k is equal to 5, or actually it's not or, it's and negative 1. You switch both of their signs. Same with here. This is already in factored form. This is what's so nice about it, that you actually get the signs or the solutions without doing any equations. Now something you want to look out for, especially in the factored, is that this could happen where basically your x is not singular. The x must be singular for you to actually get the solution, which the solution to basically get the x out of this is to divide whatever number in the whatever number is in the bracket by 4. What do I mean by this? Is that you see how this is a positive 5, so x is equal to negative 5 over 4, and then your other solution would just stay the same since it's already in singular k or x form, I guess. This would just mean negative 1. This is also in factored form. You have 3 and 3, so the first m, you see how this is already in 2m, so you'd have to, the first m would mean negative 3 over 2, since you have to divide it by the number that's, by the x number that's in the same bracket. And you have 4 over here, so the other one would actually be negative 3 over 4. You see what I'm getting at here? You're just dividing it by the x amount inside of the same bracket. Now we've reached the part where we can actually just do most of this via calculator. Just make sure every number is in the same place. For example, this negative 5 is going to get into here, and it's going to be 24 plus 24. Now you can plug everything into calculator. Mode 5, 3. First number was, just put it next to it. Oh, I hope you guys can see it. Yes, you guys can. Amazing. You have 1x, negative 11, and then positive 24, which should give you the answer of x is equal to 8 and 3. You don't switch those signs up, you only switch them once they're inside of the bracket. Again, you want to make sure every number is on the same side, so this is going to be positive 10 instead. It's going to get minused. Reset the numbers. This is 1 plus 7. Wait, what the hell? 7 and then 10. Your n would mean, or would be, negative 2 or negative 5. all correct so far. Now again, you want to make sure that all of your numbers are on the same side. Also make sure, please, math, physics, chemistry, English exams have a very good night's sleep, because they need actual concentration. You could get confused in the numbers. Numbers are really easy to get confused by or mess up in. That's why you really want to have a really good night's sleep, or you want to write everything out in front of you like I am doing over here. You'd get this inside, or like you'd switch the places for this, and this would be 24. So you'd have 1, -10, and then 24. Wait, yeah, 24, which mean n is equal to 6 or 4. These are your solutions, by the way. Now, next is going to be this. You're going to switch sides. This is going to be -18, because you're going to be adding, it's going to be -6, -6 and -12 is -18. You're going to 1 plus 3, and then you have -18, which would be x is equal to 3, the other one being -6. Before the last one would be, you'd switch it in, -6 and -18 would be -24. Okay, now this is something new that we haven't seen throughout this throughout the whole equations. You have a number over here that is not 1, so you're just going to plug it exactly the same. Just plug in the same numbers that you're looking at. It's going to be 6, -18n, and then -24. The answer is going to be n is going to be equal. By the way, the variable can literally be any type of letter, so don't worry if it's like K, Q, whatever. Just know he's talking about the variable. Of course, the locations don't change. The power 2 is first. The power 2 is always placed first. Then the variable one is placed right before, and then it's just normal number. I think it was a lesson called polynomials, where variables are always placed before. So like variables always placed before in numbers in terms of this consequence, and then you'd have whatever power, and then the higher you go, the more they are to the side towards the equal, of course. No, further away from the equal, I believe. Yeah. Oh wait, are they further away from the equal? Wait, scratch that. Doesn't matter. That's beyond our lesson. Now last one is just, you're just going to get this 7 in, which means it's just going to be +7. -14 r, and then you have just a normal 7, which would be actually one solution. And what did we say about having one solution? That means the discriminant is exactly at the x-intercept, or 0. The x would be equal to 1, or the r. We'll just replace that. Yeah. As a little fun exercise to go through all of these, here the discriminant is actually over 0. Here the discriminant is also over 0. Discriminant is over 0. Any two real solutions, discriminant would be over 0. Discriminant here would be equal to 0. Discriminant is over 0. What the hell was that? Now, of course over here it states quadratic formula, but our teachers have already informed us they just want the solutions. Now this is the same thing that we've already been doing, but let me just do them all really quickly in case there are tricks. First x will be 7. 7 and -2. Second one. 1 -4 plus 4. X is equal to 2. Oh, it's just 1. Okay, amazing. That means, let me just put that again. Discriminant is equal exactly 0. This one, number 3. 2, 2, -12. Wait, what? Did I just skip through? I skipped the answer. Okay, amazing. -3. Now number 4. 2, -3, -5. Of course, if the exam does get you these type of questions, they're gifts. Please don't mess up on them. They're all just done via calculator. Calc. Two, 3, -20 would give us, the first x solution would be 5/2 again. That makes me a little suspicious. 5 -2 and -4. Last, before actually the last one, 4, 8, 7. No, okay. This will get us to end. It's actually +3 instead. Please do not mess up like I almost did. A good night's sleep is worth it for these type of things. Of course, if you're able to. It is okay if you didn't get enough sleep. It's just going to hinder your performance. You want to be extra careful while you're solving. Now, last but not least, 2, -7, and this would actually come here. So you'd switch the signs, it would be -3. Are those imaginary solutions? No, they're not. Okay. So the first x, wow, this is very long to write out. 73/4. That's the first x. Wow. Pretty sure the other one is just going to be negative. They tend to be like that for some reason. So all over 4. Yep. Now that's all of these. Okay. Now this is a new topic that we have not solved out yet. Whoa. Okay. This magically worked again. Amazing. Is there a way to keep this from like shutting off every 2 seconds? Wait, what if I just do this? Cool. Okay. I'm gonna just leave it like this. Probably gonna shut down again. I still wonder why it does that. Okay. Now what they actually want here is just the vertex or the vertex points. They don't necessarily want the vertex form. The vertex form would need us to actually do something called completing the square. I can talk about it really quickly. It's basically you divide this middle number by 2, and then you place it inside of the bracket with the x, and then you power that number and minus it by the one outside. Of course, this could be incorrect. We haven't taken this. I just know as like general knowledge. I wouldn't depend on this during the exam if I was you. You could of course do your own research. What is this, yo? Wow, that is a whole lot of light. I hope it doesn't shut off anymore. Actually, this is, I think, really nice lighting. Let me just like try to like decrease the lighting a little. Yeah, no, I cannot control this for my life. Yeah, okay, I give up on trying to control the light. Okay, now let's get to solving. What did I do, yo? Okay, now we've already covered the standard form on how to get each vertex. So this is going to be negative b. This is in standard form. Let's just search if there is anything that's not in standard form. There is nothing that's in, oh wait, number 14. Okay, we'll reach there. Negative b over 2a, which would mean this is negative 16 over 2. Of course, the 2a being this one, being the x power 2, which would give us negative 8. That would be our x. Now let's substitute back. Of course, we're not going to do this by hand. We're just going to do this by calculator. This is going to be between brackets. Make sure to put your brackets. They're really important for the powers, etc. Plus 16, then 8, then plus 71, which would give you 7. So that is actually a vertex point. It is between coordinates 7. Let me just do this for like everyone's safety. Yeah, there we go. That is the correct answer. Now, this is also in standard form. You have, again, negative b over 2a. You just want to plug each number in. This is negative and negative, so this would be 2 over 2a, which would be 2. So the x would be equal to 1. And then you just substitute it back. Oh, wow. 1 power 2 plus negative 2. And then you put between brackets 1 and then negative 5, which would give you negative 6. So that is your vertex coordinate. Oh, I forgot the negative. There we go. Standard form again. Negative b over 2a. So you'd have this negative 14. So it would be negative 14 normally. And then our 2a is actually in negative. So it would be negative 2, which would give us negative 7. That is our x coordinate. Let me just put it between brackets. You substitute back in to the question. You put negative and then negative 7 power 2, negative 14 between bracket negative 7, and then minus 59, which would give us negative 10. Amazing. Again, this is not how you get the x-intercept. This is how you get the vertex point, which is the minimum or the maximum. In this case, number 3, this would be the maximum since this was negative. I doubt they're going to question you about this, but just for like general knowledge, you'd want to know how quadratics work and functions work in general. Now this is again standard form, so negative b over 2a. I'm starting to forget myself, holy. Negative 36 over 4, which wait, let me try actually doing that by my head. It's negative 9. Negative 9 between brackets, that's your x. Substitute back, negative 9 power 2. Make sure you're using brackets. 36. It would be 8. Amazing. Now, just to give a really quick example why you need to use brackets. Let's say you didn't use brackets with the negative 9. Over here, you just substituted them in. Your answer would turn into negative 223, negative 233, and that's only regarding the first bracket. I don't think the second bracket is as important. Let me just put it over here. Yeah, it still stays the same. So why is it important? It's because of the power 2. It actually removes the negative, I believe. And of course, exponents are done before spam does. Exponents are done before multiplication. So it would then be multiplied by 2. Standard form again. Negative b over 2a, which would be negative 12. No, it would be 12 over 2, which is 6, and that is our first point. Then we go back, we substitute back between brackets, of course, 6 power 2 minus 12 in brackets 6 again, then plus 46, which would be 10. That is our vertex for this question. Now over here, x plus 4, for x you'd have negative b over 2a again, which would be negative 4 over 2 gives us negative 2, and then you'd replace it back between brackets, negative 2 power 2 plus 4 between brackets negative 2, which would give us negative 4. Standard form again, negative b over 2a. You put negative 6 cannot work, you'd have to put positive 6, they cancel out each other. Then you'd have 2, 3, our first point. Then you substitute back. Oh, almost forgot the brackets. 3 power 2. Oh, minus 6, 3. And then plus 5. That gives us negative 4. There we go. Okay, now here is a little problem that we have. This is the factored form. This would be amazing. Amazing to get the x-intercepts, or like solutions for the equation. Now, what did we learn? Since we didn't use this for a long time, I can get us the sheet that we have. The sheet says, where it is, yeah, we switch both of the signs, and then you put them over 2, and then you switch back into the equation to get the y. We're going to do that. It's negative 5, negative 4 over 2, which would be 4.5. Yeah, it is 4.5, or negative 4.5 to be specific. And then you substitute back, which would be, let me just put this between brackets, that's our first point. That's our x, by the way. Oh, I literally just forgot the whole equation. Negative 4.5 plus 5, and then between brackets, and then negative 4.5 again, minus, plus 4, yeah. Amazing. It's 1 over 4, or I personally like to always put my numbers in decimals, 0.25. I like working with decimals more than fractions. Now this one is a little tricky. You could of course just go in and multiply both of them by 2. You'd multiply, so it would be 2y plus 8 equal x minus 7 power 2. And then you just put over there, it's going to be 2y equal x minus 7 power 2 minus 8. Now, does this look familiar to you? This looks exactly like the, what was it called? Oh yeah, the vertex form, which then would you just divide it by 2. So it would be y equal x minus 7 minus 4. This of course stays as power 2. So your solution here would be 7. Oh, of course, yeah, you switch the sign over here, and then you, yep, there it is. Oh, this is standard form. Let me just take this over here. Then you'd have negative y. You don't want to ever have a negative y. You'd rather just switch everything else. So instead of that, I'll put negative 6 x power 2, negative 12 x, and then negative 13 and then you do, of course, negative b over 2a, which would be 12 over 2a, which is actually negative 12. So this would be negative 1. That's your first point. Then you substitute back. Negative 6 between brackets, negative 1. Oh wait, power 2. Holy. Do not forget that. Negative 13, yeah. Amazing. And something went wrong. Oh. There we go. Yeah. Do not forget your signs while you're substituting. I just got 33 while the answer was 7. Holy. Okay. Now we run into the same problem where y over here is negative. So I'd actually send y over there. Or actually wait, no. We could send the 9 over there. It would be positive 9. And you could just switch all of the signs. So it would be negative 9x. And then it would be negative 162x. And then also negative 731. This is also standard equation or standard form. Negative b over 2a. 2a, which would be negative, it'd be 162 over 18. Negative 18, please don't forget that. By the way, solving too much equations can exhaust you. That's why. Negative 9, that's your first point. Now substitute back into the equation, which would be negative 9. And then between brackets, negative 9 again, power 2, minus 162. Between brackets again, negative 9, minus 731, which would be negative 2. Okay, back to this. Okay, y is already positive here, so I'm just going to switch the signs of everything else. It's going to be negative x2, positive 12x, and then negative 40. Negative b over 2a, yeah. Which would be negative 12 over negative 2, which is 6. Here's our first point. And then you substitute back. Negative outside of the bracket, then 6 inside. Power 2 plus 12, 6, minus 40. And the answer is negative 4. Amazing. We're going crazy. We're almost done already with this part of at least. Negative b over 2a, which would be negative 10 over 2. Yeah, negative 5 between brackets. Yeah, then you substitute back. Negative 5 power 2 plus 10, negative 5 plus 33, which would be 8. Is that correct? Yep. Amazing. Now, as you can see, this question stands out. Number 9, number 14 stand out because they're both in A2, because they're all in different forms other than standard. 9 and 14 are specifically in vertex forms, so all you do for this is just send the 6 over there, and then you switch the signs for 3, and then it would be negative 3 since we switched the sign of whatever's inside the bracket for the x-intercept, or the x-coordinate, and then when you send the 6 over there, it's going to be negative 6, and that is our answer. And with that, I think we finished most of the quadratics. This should be the last sheet of quadratics, which talks about discriminant. Now, there are two ways to do this. You could just speed run through the discriminant by using the calculator, using mode 5.3, which would, of course, you could just plug in the numbers or plug in the equation, and it would give you if it has 2 real solutions, if it has 1 solution, or just 2 complex imaginary ones. And let me just write down the cases for you. If d is over 0, it has 2 real. If d is equal to 0, it has 1 real. If d is less than 0, it has 2 imaginary. Or just complex, I guess. Or just no solution. These are the 3 cases for the discriminant. I think I'm gonna go by hand. I'm going to do this by hand, showing you how to do the discriminant since it explicitly asks for so. So let's go over this really quickly. Discriminant is, oh wait, did I not write you guys the discriminant equation? I did write it, but I don't think I said it. The discriminant equation, by the way, is b power 2, oh my days, equation is equal to b power 2 minus 4ac. Of course, everything is put in brackets once you're substituting in. Let me just put it over here. Okay, let me just sort everything out since everything is just so messy across both sides. This is going to be 9 power 2 minus 3n, and then when you take this inside, it's going to be plus 2 negative 2x power 2 minus 8x, and then when this goes in, it's going to be yeah, it's going to be negative 8 instead. I mean, does it matter which side it is? I don't think so. So you could just negative 4a power 2 positive 8a negative 4 9m power 2 plus 6m plus 1. This would be 9b power 2 minus 8b plus 8. This would be negative x power 2 minus 6x minus 9. Over here be negative 4r power 2 minus 4r minus 6 8b. Oh my days, that's not right. Okay, when this goes in, it's going to be 3b power 2 minus 6b plus 3. Now we've sorted out all the equations, we can actually start solving using the discriminant equation, which is b power 2 plus 4ac. Wait, b power 2, yeah, it's going to be negative 3. Wait, should I even be writing this? No, I'm not going to write this. It's going to be between brackets, please. Yeah, there we go. Power 2 minus 4, and then between brackets for a, our a was 9, and then between brackets again c, which is 2. Our answer is negative 63. Discriminant is equal to negative 63. Now negative 63 of course is under 0. This would mean it's too complex. There we go. On to the second one. b power 2, which would be negative, between brackets, negative 8 power 2 minus 4, and then between brackets again a, which is 2, and then c between brackets again, which is negative 8, is actually equal to 0. Our discriminant here is equal to 0, so that means it's one real solution. Negative, okay. No, that's not negative, yay. 6 power 2 minus 4. Wait, for AC, yeah. 9 and then 1. It's also 0. So our discriminant here is equal to 0. This would mean 1. real solution. It would be between brackets 8 power 2 minus 4 minus a, which is, okay, something we want to look out for, of course, is negative signs. It's AC, negative 4, and then between brackets again, what? It's four negatives in a row. Negative 4 3 times, which would be 0. Equals 0. 1. Okay. Between brackets negative 8 power 2. Wait, am I actually not showing you guys the calculator? Wait. Oh no, I am. I just keep moving it out of camera, I guess, or out of sight. Sorry. Then I'll just move this out of sight instead. Okay, so anything out of my shadow is just... Okay, cool. I'll just keep it in the middle, I guess. Wait. Yep, pretty cool. It's negative b power 2, yeah. Negative b power 2 minus 4, and our a is 9. And our C is 8. Wait, is this correct? Negative 224? Yeah, that is amazing. Our D is actually smaller than 0, so it would mean 2 complex. I'll just place it down then, whatever. Negative b, which is negative 6. Negative 6 power 2 minus 4, and then negative 1 for AC, and our C is 9. There's our answer. What are your solution? I think we can just place this up here now. Yeah, y'all can see with it up there. Amazing. The answer is 0. D is equal to 0. 1. Real solution. Okay. B power 2, which is between brackets negative 4 power 2 minus 4 AC, which is minus 4 again, and then between brackets negative 6, which would be negative AC, which our D is actually smaller than 0 once more. So that means it would be 2 complex. Honestly, complex solutions genuinely make me wonder. They're so confusing to deal with. Okay. B power 2 again, which is negative 6 to the second power, minus 4 AC, which would be 3. Then, wait, is it 3 3? Yeah, it is. 3 3, which is also equal to 0. Our D over here is equal to 0. 1 real solution. With that, we solved everything regarding the quadratic. Let's move on to the arc length and area of sectors. Remember how I said the arc length is basically theta whatever angle over 360 times 2 pi r. This is the circumference. Yeah, there we go, that's circumference, and this would be the rule of the area. Basically we're going to do the same thing. Over here, exercise A, it asks for, I think they're asking for the arc length, yeah? Oh yeah, it is. They're asking for the arc length, which would be theta, which is 45 over 360 multiplied by 2. What happened? There we go. 2 pi times the radius, which is 14. The answer would be 10.9 0.95, which I guess you could just say it's 11. Also make sure to put the centimeters. Some teachers do conduct marks for the measuring rate or the measuring tool. Same thing with this, you do 80 over 360 times 2 pi, and then you have 5, which is your radius. The answer would be 6.98 or just 7 centimeters. Moving on to the area. The area already, we covered it in the last page, I guess. It would be the whatever theta over 360 times pi and times radius to the power of 2. Now, actually over here it asks for the circumference, not the area, so we'd use the there is nothing to do over 360, so we could just place it as 1. We'll just do 1, or we don't even need to do 1. It's 2 pi. Okay, we'll stop doing that. 2 pi times what's the r? The r is 5.7. 2 pi times 5.7. The answer would be 36, basically. He's asking for the radius. He gave us already the circumference, so you do actually shift solve over here. So it's 94 equal 2 pi r, or in this case it would be x. Let's shift solve. It is, wait, no. Am I losing it? Oh, my days. I am. Yeah, it is 14. What made me go back? It's 14. Yeah, it is 14.96. Now we're back to using the arc length. The arc length he already gave us the angle, so you'd use one, which was 145 over 360. The arc length used 2 pi, and the radius, which is 14.2. Your answer would be 35.9, or I guess you could just say 36. 35.9 slash just 36. Now it also asks for the length again. Gives us an angle 130 over 360 times 2 pi, then the radius 15.4, which is 34.94 or just 35. Amazing. He asks for the length of AB. He gives us the angle 67. By the way, this is a central angle. This is also 67. If there was an angle extending to here, it would be the half. Just getting us a warm-up for upcoming pages. So it would be 67 over 360 times 2 pi. Then you have 30.8, which gives us 36.01, and of course meters for some reason. Number 6, he wants the area of the circle, and he does give us the radius, so it's going to be pi, then multiplied by the radius, which is 3 over 8 to the second power, which is 0.44.1. Number 7, he also wants the area of the circle, which would be pi times the radius, which is 3.7 this time, to the second power, which would be 43. 40.008 centimeters. There we go. And this is in inches. If this is 60, this is also 60. We have the angle, and he wants the area of the sector. So this would be 60 over 360, and then multiplied by pi, then multiplied by 8 power 2, because 8 is our radius. And the answer is 33. 33. Holy. 5-1. Number 9. He gives us an angle. He asks for the area. The area rule is pi r power 2 and like whatever theta over 360. So in this case it would be 110 over 360 multiplied by pi, and the radius being 12.8 power 2. You get your answer. You'd also press this if you get like a decimal or like pi answer. You generally want to write all of your answers in decimals, not fractions. Or actually, I think fractions are accepted. Again, this is just preference. He wants the area of the circle and the sector JMK, and he gives us wait, what? Find the area of the circle. If area sector JMK is... Oh, so he does give us the area? Or does he not give us the area? Okay. Yeah. Oh, he does give us... This is not the area. I think this is meant like the radius. Maybe. Anywho, let's do 58. That is not 50. 58 over 360 multiplied by pi multiplied by 36.07, the second power, and that is not the answer. What does he want? Wait, 36.07. Oh, he wants the area of the whole circle. Okay, I'm smart. Thanks. If he already gave us the angle for this, so we just need to do. Can I? Thanks. This would be 58 over 360 multiplied by pi, then multiplied by x power 2, and that is not x. X power 2. Shift solve. Now you'd get the radius. The radius is 8.44.1. You want the whole area, so it would be pi multiplied by 8.44 to the second power, which would give us 223.786, and this is in centimeters squared. With that, we should have solved all the length and sectors. Moving on to the inscribed angles. We already know any straight line is equal to 180. So we do this 3x plus 5 plus x minus 1 is equal to 180. You substitute, you wouldn't say, you'd move this over there, it would, and you put them both together, it would be 4x equal 100. Minus this by 1, it would do 176. When you do that, 176 divided by 4, it would be 44. So the angle would be 44. Now this is an inscribed angle. Remember how I told you anything inside is basically half outside? Yeah. This is an inscribed angle, and this is central. This would be 100. That would also be 100. This is a straight. This is a hemisphere. This is 90 degrees. I'm pretty sure this is also something called like an isosceles or something, where this is 50, this is also going to be 50, so this is going to be a 50-50. Okay, any triangle needs to be 180, this is 80, so x is actually 40. That means this is also 80. If we're removing this, if it's just this, it would be 80, and then yeah. This is 90, and then you'd have 90 plus 37 minus 180, 53. Your answer is 53. We did that by adding these two and then minusing them all from 180, which gave us the remainder, which would be this angle, since they have to be 180 total. Now, this is a tricky one. Basically, you have to play blind with one of them. Remember how I told you anything going from the center is a central angle? You can try removing the middle line and this line. It would look as if it's just coming from here. Like, let me just extend it. You see these two lines? This is just a normal central angle. Ignore anything in it. So this would be 70. Anything behind it, at the edge of the circle, would be half it, would be 35. Now, as you can see, this is basically at the half of the circle. It shares the same legs, so this would be 35. They are a little confusing. You do generally want to know, you want to be able to like act blind to most of them. Since this is just 70, you would know that this central angle, anything at the edge would be half of it, especially if it shares the same legs too. This was also confusing. Remember, wait, let me just think about that for a second. Yeah, these two, the same, because they're in the same segment. I mean, let me just flip it. They still share the same legs. Remember when I said segment 1, this is segment 2. Anything in the same segment sharing the same two lines across the edge would be the same. So if this is 50, this is also 50. And this is also right angle triangle. You could just look, you see this, and then you could see this. This is 90, this is 90. What does it want? It wants CAB, C, okay, CA, oh, it just wants C, okay, cool. If this is 90, this is 50. The rest has to be 40. Since 50 plus 90 is equal to 140, 140 minus 180 is equal to 40. That's how you get your angle. He wants ACB, the x over here. Anything already, this is a central angle, this is an inscribed, the edge of the circle. This would be exactly half, which is 67.5. Now, last one. We have both of these angles, but we do not, what does it want? It wants the x. This already has to be a full 180, so you do 70, 70 minus 180, that is 110. Now, 110. Yeah, you'd have to multiply this by 2. 110 times 2 is equal to 220. And then you do 220 minus 360, which is the whole value of the circle, and it would be 140. And with that, we've officially finished the whole sheet. I could run through it really quickly and correct it on camera, although I'm pretty sure everything is correct. But for the sake of completeness, let me just do it. Yup. Actually, is that what would we even care about? Should we care about any of this? Should I just go to the quadratic? Wait, did I get this incorrect? Oh, I circled the wrong thing. I'm pretty sure we saw the right thing on the calculator. I just circled the wrong thing. Whatever. This is C. 0. Yup. Onto the quadratics. -1 on 5. Yep. Yup. Yup. I think it would be safe to say the rest should be correct. I just want to make sure everything is correct before I finish the video. In case we do find mistakes, we can go over them really quickly. Over 6. Yeah. And almost done. Seven, -4, 9 and 2, 5 and 8. On to 2 complex, 1 real, 1 real, 1 real, 2 and 2, and this is also 1 real and 1 real. This is 11, this is 7. Wow, that rhymed. $36, 15, again, 36 again once more, and then 35. That, yep, 43, 33, 200, 100. Now should be the last ones. 44, 100. Wait, very quickly. Yeah, 90. Almost done. 40, 53, 35. Now lastly 40. Correct. And now okay, and with that we officially finished the full math revision. I hope you guys can actually benefit from this. I hope I helped you guys. Again, this is all my information. I do understand if something or my methods could be incorrect. I did my best to really show that, or like not show, I did my best to make sure that everything is correct. Now, in case you guys want to take screenshots of this, here it is. This is the first study sheet I made, and this is the second one. This is for the circles. And with that, thank you for watching.